Four important concentration terms I am going to discuss today. These are mass by mass percentage, mole fraction, molarity, and molality. Okay. So let us start the first one, mass by mass percentage. Mass by mass percentage, or briefly you can write W by W percentage. This is equal to mass of solute by mass of solution into 100. Okay, so we can understand this by means of a simple example. So example number 1, calculate the mass percentage of a solute in a solution prepared by dissolving 20 gram of solute in 180 gram of solvent. Okay. So here mass of solute is denoted by W1, W2 sorry, is equal to 20 grams. Mass of solvent W1 is 180 grams. Okay, I hope you can see it clearly. W2 is 20 gram, that is mass of solute, and mass of solvent is W1, 180 grams. So mass of solution is given by W1 plus W2 is equal to 20 gram plus 180 grams. That gives 200 grams. So total mass of the solution is 200 grams. So now mass percentage of solute is equal to W2 by W1 plus W2 into 100. That is mass of solute divided by mass of solution. Mass of solution is W1 plus W2. So it is 20 gram divided by 180 plus 20 gram. That is equal to 20 by this much into 100. 20 by 200 into 100. Okay, that gives 10%. Okay, so the mass percentage of solute in this solution is 10%. Okay, so first note down, then we'll go to the next part, that is mole fraction. Okay, so the next concentration term is mole fraction. Okay, Suppose consider a solution which contains N2 moles of solute dissolved in N1 moles of solvent. Okay. So suppose we have prepared a solution which contains N2 moles of solute dissolved in N1 moles of solvent. So mole fraction of solute is given by x1, better to denoted by x2 is equal to N2 by N1 plus N2. So mole fraction of solute is given by x2 is equal to N2 by N1 plus N2, and mole fraction of solvent is given by x1 is equal to N1 by N1 plus N2. Okay. Now a special notable point. The sum of mole fractions of all the components of a solution is equal to 1. Okay. So we can briefly note down like summation of xi I from 1 to n is equal to 1. That means if there are n components of a system, the summation of mole fraction of all the n components is equal to 1. Okay. Next one, for a binary solution, what is the relationship? Binary solution means a solution having two components, that is one solute and one solvent. So for a binary solution, sum of mole fraction, that is x1 plus x2 is equal to 1. That is mole fraction of solvent plus mole fraction of solute is equal to 1. So we can calculate x1 if you know x2. So x1 is equal to 1 minus x2, or x2 is equal to 1 minus x1. Okay. So we can understand this concept clearly by means of one simple example. Example 2 for mole fraction. Okay. Calculate the mole fraction of sodium hydroxide NaOH in a solution prepared by dissolving 80 grams of NaOH in 360 grams of water. Okay. So here the solute is sodium hydroxide and solvent is water. So first we have to calculate the number of moles of sodium hydroxide and the number of moles of water. So number of moles of sodium hydroxide, here solute, so we take N2 is equal to W2 by M2. So here given mass of sodium hydroxide is 80 gram and M2 is the molar mass of sodium hydroxide, that is 40 gram per mole. Okay, so that gives N2 is equal to 2 moles. Okay, so N2 is equal to 2 moles. Like this we can calculate the number of moles of water also. Number of moles of water is given by N1 is equal to W1 by N1. Okay. W1 is the given mass of water and M1 is the molar mass of water. That is 360 gram by 18 gram per mole. Okay, so that gives N1 is equal to 20 moles. Okay, so here we have calculated number of moles of solute 2 moles and number of moles of solvent 20 moles. Okay, so then we have to calculate the mole fraction of solute. So now mole fraction of solute, that is sodium hydroxide, H2 is equal to N2 by N1 plus N2. So here N2 is 2 moles and N1 we have got 20 moles plus N2 is 2. So that gives 2 by 22 or 1 by 11. We can convert the mole fraction into decimals also. Okay. So thus we get mole fraction of solute is 1 by 11. Okay. So this is a simple example by means of which you can understand the concept of mole fraction very easily. Okay. So next example goes for molarity. Okay. Molarity is denoted by capital M, which is equal to number of moles of solute divided by volume of solution in liters. This is very important. Sometimes the volume is given in milliliter, so you have to convert the volume into liters. Or we can write briefly M is equal to N by V. N is the number of moles of solute and V is the volume of solution in liters. Or number of moles is equal to molarity into volume. This is very important. Sometimes molarity is given and volume is given in milliliters. So in that case you have to convert volume into liters. Okay. So let us understand this concept by means of one simple example. So example 3. Calculate the molarity of a solution prepared by dissolving 20 gram of sodium hydroxide in enough water so that the final volume of the solution is 2000 milliliter. Okay. So here volume of the solution is known in milliliters and mass of solute is known. So first we have to calculate the number of moles of solute. So here number of moles of solute N2 is equal to W2 by N2. That is 20 gram by molar mass, 40 gram per mole. That gives 0.5 mole. Okay. So here number of moles of solute is 0.5 mole and volume of the solution is 2000 milliliter. So we have to convert this volume into liter. That is 2000 divided by 1000. That is 2 liters. Okay. In order to convert volume in milliliters to liter, we have to divide by 1000. So here you have got volume of the solution in liters. Now molarity of the solution given by capital M is equal to N2 by V or N by V. Here we have taken N2, so you can put that 0.5 by 2. Okay, that gives 0.25 mole per liter. Okay, so always don't forget to write the units. So finally we got molarity is equal to 0.25 mole per liter. This is the final answer. Okay, so the unit of molarity is mole per liter. Okay, next concentration term is molality. Okay, note down this one. Molality given by small m, and here number of moles of solute in the numerator, and the denominator you have to write mass of the solvent in kg. This is very important. Mass of the solvent in kg, in kilogram. Okay. This is a very notable point because sometimes students forget to write solvent, or they think it is solution. Okay, that is incorrect. So this part is very important. This is the mass of the solvent in kg. Okay. So here we have to explain this concept by a simple example. So let us go for example 4. Calculate the molality of a solution prepared by dissolving 18 gram of glucose in 1800 gram of water. Okay. So this is a direct question. To understand it very simply, in a simple manner, we have to give simple values. So here mass of solute, that means mass of glucose W2 is 18 gram, and the molar mass of glucose the formula of glucose all of you know, C6H12O6. If you add all the atomic masses, that gives you 180 gram per mole. Okay, molar mass is always mentioned in gram per mole. So number of moles of solute N2 is equal to W2 by M2, that is 18 gram divided by 180 gram per mole, that is 0.1 mole. Okay, so number of moles of solute is 0.1 mole. So now molality is given by N2 by W1. W1 for mass of solvent in kg, that is 0.1 by mass of solvent. You see, it is 1800 gram. So 1800 gram means 1.8 kg. 0.1 mole divided by 1.8 kg. That gives 1 by 18. Okay, 1 by 18 mole per kg or kg inverse. Okay. So I think this is very easy to understand, because in this question I have given you mass of solute, that is mass of glucose, and mass of glucose divided by molar mass of glucose gives you number of moles of glucose. So 18 gram divided by 180 gram per mole, that gives 0.1 mole. Okay. So the final answer, the final molality is 1 by 18 mole per kg. Okay. There is a very notable point. Out of molality and molarity, which one is not dependent upon temperature? So here the answer is molality, because in case of molarity, the numerator is number of moles and denominator is volume of solution, but volume of solution changes with temperature. But in case of molality, here the number of moles of solute is same as that of molarity, but mass of solvent in kg, that doesn't change. Both the numerator and denominator do not change with temperature. So we can note down molality does not change with temperature. Okay. So this is all about molality, and this was a very simple example to understand. Okay. So next class I will be discussing some more examples asked in entrances, several in the NEET or JEE main entrances. Okay. So in part 2 we will discuss some entrance questions. So thank you for watching.